the best path we seek. Minimize the distance, y minus x beta, so meek to the closest spot we yearn to reach. To minimize the distance, what do? Differentiate by beta, that's our cue. Find the beta where the derivative is zero, the optimal solution we're drawing near, you know. Least squares, distance, derivative, zero. Normal equation, its secrets will throw. Beta equals x transpose x inverse x transpose y. Unknown coefficients, find them, truth you'll know. Vector differentiation, what's it mean? Gradients in each direction, partial derivatives of vector seen. Move a bit and changes appear, that's the gradient, the rate is clear. What's the function we aim to minimize? Square distance, y minus x beta, transpose y minus x beta. In its form expanded now, three terms arise. Y transpose y2 beta, transpose x, transpose y beta, transpose x fills x beta before our eyes. Distance, derivative, zero. Normal equation, its secrets will throw. Beta equals x transpose x inverse x transpose y. Unknown coefficients, find them, truth you'll know. What happens when we differentiate? I transpose y vanishes, beta's not its mate. 2 beta transpose x transpose y becomes 2x transpose y. Inner products differentiate. Beta transpose x beta turns to 2x transpose x beta. Quadratic forms differentiate. X transpose y minus x transpose x beta equals 0. The equation's set. Normal equation we derive, the solution we get. Beta equals x transpose x inverse x transpose y. The answer's met. Least squares, distance, derivative, zero. Normal equation, its secrets will throw. Beta equals x transpose x inverse x transpose y. Unknown coefficients, find them, truth you'll know. Linear regression to find coefficients, grace. Least squares we use to set the pace. Distance minimized, normal equations